I've finished wiring my modifications and recapping, and got this board mounted back in, so it is time to do some power-up tests. First thing I want to try doing is check that the filaments work. Here's my polarized plug and cord. Now I don't have the picture tube installed. I removed that to make the set easier to work on, and I glued on the loose base while I had it out. And I want to check the filament continuity before I put the picture tube back in. So I've simply taken a power resistor and inserted it in the filament pins. And I believe all the other tubes are installed. Now remember, it's not just filament continuity I want to check. I want to make sure that my modification is going to be alright. So I took out the huge power resistor that was down here. And instead of that, I'm using, it's a little hard to see, but there's a 1N4007 diode and a thermistor in place of that, which should limit the power and dissipate very little heat and provide a soft startup with that thermistor. So I will rig up a meter and power, and let's see what kind of current draw we get. Here's my multimeter connected in series. I pulled out one end of my dummy load simulating the CRT filament and stuck another pin in there and then hooked my ammeter in series. Now without the thermistor, what you would see is the current would immediately spike up several amps and then start coming down as the tube's warmed up. This should be the opposite. It should come on a low current and gradually rise as the thermistor heats up. So let's see what happens. That went up, but only an amp, which is not bad. Now as the thermistor warms up, it should go, well actually, you know, that really depends on this meter, just occurred to me. What I was about to say before the fireworks started is that we are unlikely to see the actual current flowing through the tubes on this meter. Why is that? Well, I'm putting a diode in series with the tube filaments, which forms a half-wave rectifier, so instead of having AC current flowing through the tubes, we're going to be getting pulses like that. If you want to find the actual current flowing when it's a complex waveform, you're going to need something like this, a true RMS meter that can handle a complex waveform. Now, I like to do that, and I'll try, but I think I've blown the fuse in this. So I'm not sure the current mode is going to work. I'll try it. If it doesn't, well, then what can you do? Well, you can just eyeball it. If you've got experience with tubes, you know what a normal tube filament glow should be, and if it seems about right, you can go by that. Now, as for what were the fireworks, I don't know if that was on camera or not. I'll have to go back and review the footage, but I started seeing some flashes and some smoke coming from somewhere over here. Eventually, I tracked it down to the horizontal output tube. This lead got pinched against a screw down there. Got mashed against it and it arced right through the insulation to it. I'll have to see about replacing that, put some insulating tubing over it or something. In the meanwhile, I'm just going to, I'll throw some electrical tape over that and bend this lead so that it's out of the way, and then resume with the testing. Alright, I've got a little band-aid on my wire and I've rotated it away from that screw. And it turns out that the fuse is good for my AC amp mode, so we can use this meter. Now let's see what it has to say. Turn on, surged up a bit, drop down. And let's hope there aren't any fireworks again. That's curious, it's about the same reading as I got with the other meter, 0.4 amps. I was expecting closer to 0.6 amps, but because the tube glows do look a bit right. Now, there is one other thing I can do. I know this is a true RMS meter when it comes to voltage. Maybe the current isn't. So what the other thing you can do is put this in the AC volts mode and put the leads across a tube filament and see what kind of voltage drop you get. Like for like a 6.3 volt tube, you have about 6.3 volts going across it. Alright, now I should be able to get some sound. All's right.
Are also involved in Restaurant Week, and just about everybody was there. So good time was had by all, and I did confirm. I ran to Don Welch, who is the
and now the fine tuning is having an effect.
Chicago runs Choose Chicago, and by the way, if you look,
just good.
Week or any other Chicago activity for that matter, just go to their website. It's a good one, ChooseChicago.com.
Now I've got it set up so that it's in AC voltage mode and it's across the filament pins and horizontal output tube, which should be a 6.3 volt tube, and I've actually got about 8 volts. So a little higher than I was expecting. So I'm going to check a few other tubes. The other thing I want to check is, are these devices getting warm down here? The fusible resistor and the thermistor. So I'm going to turn the set off. It's been running a couple minutes. And thermistor, or rather fusible resistor, warm, but barely. I'd say about a watt of dissipation, which is just about what I figured, considering how much the current the set draws. In thermistor, similarly, I'd say about a watt of dissipation or so. In other words, I can put my finger on it, I'm not getting burned, but it's warm. It's definitely warm. So that's cool, yeah. In fact, these are not dissipating anywhere near enough heat that I'm really concerned about anything overheating in that area. 1 watt is no big deal. So I'm going to try a different tube now and see, because tube filaments aren't perfect. There could be some variation in them. So I'll try this guy down here. It should also be I think a 6 volt tube, maybe a 12. Huh, now I've got my voltmeter across 6cm7, which is actually the last tube in the chain. So I got one side of the clip just going to ground, the other pin 4 in that tube. And this is only a little over 4 volts. So could there be that much variation in tolerance in the tubes that they actually do have the correct filament current going through them, but the voltage drop is that much difference? I'm not sure, but I'll try a few. Another thing I can do is keep my lead clipped here and put the other end to the top of the filament chain. I should get around 85 volts total. In fact, that's really easy to do, because that is this guy right here. Only 57 volts. Now I think that this meter just really can't measure this voltage properly. Let's put a scope on that and see what the waveform actually looks like. Because there's no way there's as little as 57 volts RMS across these tubes. Because they are all lit up, the glow looks correct. It seems to be working. I'm getting sound for sure. And that should only be happening if there's 85 volts or the equivalent thereof across the tubes. Now it turns out I was incorrect. The horizontal output tube is not a 6 volt tube, it's a 12 DQ6, 12.6 volt tube, and the 6cm7 is about 6 volts, so I got about 8 volts on that, 4 on the other, so they are actually both about 30% low. I've got my scope connected across the entire tube filament string, so it should be about 85 volts RMS, and I've got about 80, and it looks like it should, halfway rectified. but the meter shows 60 volts. Now the Fluke 27 FM version is supposed to be a true RMS meter. I gotta double check the specs on this because that sure isn't what it should be. Now when I crunched the numbers, I've estimated I should get 85 volts with that half-wave rectifier and the thermistor, but I just remembered I'm running this on 117. I did my math at 125, so let's turn this up a little. And look at that, just shy of 85 volts. So I'm confident this is working perfectly. I trust my scope and the true RMS reading on it. So now I'll try to go on the internet and do a little bit of research on that guy. And now let's check the B+. Well, I did some research online and everybody says that the 27 FM, when it's marked on the display, should be true RMS, but this one most definitely is not. So I may do a separate video and pop this open and see what's actually inside of it. Kind of a bummer because I was really expecting this to be a true RMS meter. I just have to pick myself up another one. Now as for the B+, I'm testing at a point where it should be 260. I've got about 273. I assume it's higher because I used not only silicon diodes in place of the selenium, but also the original fusible resistor was 10 ohms, and I've only got 2.2 in there now. Well, it's really not all that much higher percentage-wise, and certainly the capacitors could handle it. Like I have a 350 volt cap at this point, so no problem there. I don't think I'm stressing out the tubes or any of the circuitry, so I'm just going to leave it the way it is. Alright, I got the picture tube reinstalled and the yoke mounted. Now while I took this off, I had to take the ion trap magnet off as well. I got it back in approximately the right position, but I'll be surprised if I don't see an image right away when I turn it on, which I just did. Well, not too bit of an image. I also messed around with the controls on the back, so probably everything's really out of whack right now. Alright, that's brightness. Put that up all the way. Let's get rid of channel.
We read them. Which is why I don't know anything about sex. And Billy.
Alright. Cool. Tuning. Contrast up. Yeah, not bad. Consider all the changes I made, the set still works. Right. And see, the fine-tuning depth control definitely has an effect now. Excellent. Now notice that cutting out there? I had noticed that when I worked on the tuner, that the tuner deck inside here and the channel clunker, it's a little bit of slop in it. And I thought about fixing it, but realistically, the channel's not going to be changed that often, and it's easy enough with a little flick to get it to work. I was really wanting to just fix up that broken tube pin and get the fine tuning working.
I blanked out. When I woke up, I smelled like a wet burlap sack. Thank God for Billy.
Here it is hooked up to a test pattern generator before I've made any changes, and it's actually not too bad the way it is. It's got a little bit of a tilt. I'll correct that by rotating the yoke. And it's off center. It's a little bit too far that way. And I can correct for that with some centering rings that are on the CRT now. Both the adjustments, both the yoke and centering rings, are a little tricky to do with the set turned on. not crazy about sticking my fingers in there, so I'm going to turn it off and just guesstimate how much to move the yoke and turn it back on. The centering's better, but I definitely got the tilt worse, so try it again. And I find it's easier to tilt things if you tip the set so the CRT is face down, then you can get at the yoke from both sides. Give it a little bit of a twist. Right. It's the problem with working on these portable sets, they're so cramped. It's hard to get your fingers in there to make any adjustments without getting shocked or burned. And still off. Almost. That's looking pretty good. Alright, this set is working just fine, so all that leaves is to finish up working on the cabinet. I still have some more paint splatters to remove, and I'll put this all back together.
For instance, if charge accounts just stop charging. Yeah, that might work, huh?
Hey, that's a good idea, Andy. Maybe then they'll think twice before running a woman for office.
By golly, I'm going down to Davis' store and cut that charge account off right now. Otis! Huh? You're still a prisoner, you know. Can I use the phone? Help yourself.